So, I'm going to zoom in. Are you ready? Okay. The graph that we are going to graph is called the reciprocal parent function. People often, sometimes they call it reciprocal. Gina Wilson called all of these graphs reciprocal. More often, people call them rational. What does the word rational mean in math? Means fraction. Ratio, fraction. Yep. So rational graphs, that means that we're going to be dealing with the graphs that look like fractions. So it is f of x equals 1 over x. That's the parent graph. So that's the graph with no transformations. Has not been shifted left or right, has not been shifted up or down. Now, if you look at this right here, is it possible to plug in 0? 1 over 0. Is that possible? No, you can't do 1 divided by 0. Okay, so what we're going to do is we're going to take an x value of 0, and we're going to say the x value of 0 is not allowed. Does that make sense? X value of 0 is not allowed. So if we think of all the points that have an x value of 0, so that could be 0, 1, 0, 2, 0, 3, 0, 4, 0, negative 1, 0, negative 2, 0, negative 3. That's going to be the perfectly vertical line, right? Especially the y-axis. So I'm putting a dotted line there. This is going to be an asymptote. Have you guys heard of asymptotes before? Asymptote? Let me go ahead and do it. Yeah, you guys could probably not see that very well. I'm going to do it in pink so you guys can see it better. Right there, can you see that this time? A little bit better. So because of that x on the bottom, we have a vertical asymptote, and we say that that vertical asymptote is the line x equals 0, also known as the y-axis. That's a vertical asymptote. Okay. And then it's a little more subtle, but if you plug numbers in for x, if you plug in like 1 over 1, 1 over 2, 1 over 3, 1 over 4, 1 over 5, 1 over 6, 1 over 7, no matter what number you plug in for x, there's no way for this fraction to become 0. So you could get 1 over 50, 1 over 60, 1 over 70, 1 over a million, but there's no number you could plug in for x that could make that fraction 0 out. Does that make sense? So f of x is another way of saying y. Since y equals the fraction, there's no way to get a y-coordinate of 0. It just can't happen. It's not possible. So here we said we couldn't plug in x equals 0. You just couldn't plug it in because it wouldn't give you a result. For y, you can't ever get y equaling 0. There's no x value that you could plug in that would make 0 happen as a result for a y-coordinate. So a y-coordinate of 0 is an output that is just not possible. No matter what you plug in for x, you could never get this fraction to become 0. Because you always have 1 on the top. How do fractions 0 out? How could you make a fraction equal 0? Yeah, put a 0 on the top. So since the number on the top is a 1, there's no way for that fraction to become 0. Does that make sense? So here we're going to say there's a horizontal asymptote at y equals 0. You're going to get a coordinate. You're never going to get an output of 0. And that's because the fraction has a 1 on top. It's never going to zero out. So we're going to say there's a horizontal asymptote at 0. So you can never have an input of 0. You can never have an output of 0. You can never have an x-coordinate of 0. You can never have a y-coordinate of 0. And this is kind of the unique thing about rational functions or reciprocal functions. They do not have a vertex. They do not have an endpoint. They do not have a turning point. Instead, they have an intersection of a vertical asymptote and a horizontal asymptote. So that's what we're going to look for in these problems, okay? So let's go ahead and graph this. It's 1 divided by x. So on here, we're going to hit y equals. Now, you can type 1 and then use the division button. 1 divided by x. This one's pretty simple to type. 1 divided by x. Or you can use your fraction button. So your fraction button is alpha, the green button, alpha y equals. That's how you're going to do it. And you'll know if you can do it if your calculator's updated or not. So alpha y equals, if your calculator is updated, it will look like this. Not updated, it will not look like that, and you'll know right away. So everyone try it on their calculators. Let's make sure we all have the updated version. If you have a color calculator, you definitely have the updated version. So is everyone able to type that as a fraction? 1 over x like this? Yep. Okay. Now, when you type it as 1 over x like that, it's going to make it so that all of your outputs are fractions. Fractions are hard to graph. It's easier for most people to graph decimals. So if you want your outputs to be decimals so they're easier to graph, you have to hit the math button. Everyone hit the math button. And then you have to hit number 2. Number 2 will take all your outputs and it will turn them back into decimals so that they're easier to graph. Okay, so it'll just take your table and it will say, hey, table, I wanted to graph it like a fraction. I wanted to be able to type it in more easily, but I still want my outputs to be decimals because I want to be able to graph decimals. Does that make sense? Okay, so I'm going to go ahead and show you the difference. Since all of you guys just did that, I'll show you guys what happens on my screen. So here is this. If I go through and I hit, there's my table. See how my table is full of fractions? And if you guys look at your table, if you hit second graph and look at your table should be full of decimals. Does that make sense? So that's the difference in what your table is going to look like if you tell it to do decimals versus if you don't. It will give you fractions since you typed in your function as a fraction. All right, so if we look at this, let's go ahead and graph this. So what I do is I typically would go for one of the points on either side. So the error, that's my asymptote. So on either side of the asymptote is typically where you're going to get your whole numbers. Those are going to be your points that are easiest to graph. So I always look for the asymptote first. And then I've got -1, -1, and +1, +1. So there's the first point. That's the easiest to graph. The nice thing for you guys is you guys can, you don't have to draw as big of a graph as I have. So with this, you don't need to go all the way to 10. You can probably on your paper go to like 4 instead. So these graphs on this paper, and when you do the assignment, they're going to be pretty big, but you will not need to make them near as big as they are on the assignment. You can make them pretty small. And then from there, I'd probably only do one more point. So like -2, -0.5. +2, +0.5, and then you're probably good. So -2, -0.5, +2, +0.5. And what have you guys learned about asymptotes in the past? Anyone know anything about asymptotes? Something. Anybody else? What have you guys learned about asymptotes? You don't remember learning about them? So typically asymptotes, we'll go ahead and write this. Let's write this at the top. So here's how you spell, it's a weird word, A-S-Y-M-P. That P is silent, you don't pronounce it. A-S-Y-M-P. T-O-T-E, asymptote. Oop. Asymptote. Notice I didn't pronounce the P. So asymptote is how you pronounce it. It's an imaginary line that the curve, and when I say curve, I mean like, because these graphs are not straight, right? So they're curved, so we call them curves, okay? So it's an imaginary line that the curve gets closer to. And I'm going to say often without crossing. So when you first start looking at asymptotes, a lot of teachers will describe it as an imaginary line that you get closer and closer and closer to but never cross, and that's not true. Asymptotes can be crossed, but it's in the more advanced math classes that you finally see the asymptotes you cross. For us, the asymptotes are not going to get crossed. You're gonna have the curve and it's gonna get closer and closer and closer to the asymptote, but it's not gonna cross it. So if a teacher early on describes it as, oh, it's an imaginary line that never gets crossed, and then later you see that they actually do get crossed, then you say like, oh, Miss Rice lied to me. So I'm not lying to you, they do get crossed, they just will not get crossed for today. Does that make sense? So you can think of it as a fence that you're getting closer and closer and closer and closer to, but you're not going to cross it, okay? So when we look at these graphs, they kind of look like the corner of tables is what they look like. So it looks like a rounded corner. So what we do is we graph just a couple points, and actually I can go ahead and show you guys on here, hit the graph button. So they look like the corner of tables, and what happens is it just gets closer and closer to the asymptote there, gets closer to the asymptote there, but doesn't cross it. Same thing over here, it looks like the corner of a table, and then gets closer to the asymptote right there, and gets closer to the asymptote right here. So when you draw in the asymptote, typically with a dotted line, we use a dotted line to show that it's imaginary, it's not actually there. Then when we have those dotted lines in, we can draw just a couple points, and since we know how an asymptote acts, we know that the curve gets closer to it, then we can kind of connect these points, kind of make them rounded, and then we can just follow that dotted line, draw an arrow, follow that dotted line, draw an arrow, follow that dotted line, and then follow the dotted line. So if you guys can kind of see how that looks there, you can see there's my kind of corner shape, and then it's just following out and following out. Okay, does that make sense? Okay, so that's what we're going to be doing for today. For the domain, these domain and range for these are pretty nice because you can see that from left to right, you're using all of the values except for that pink line in between, right? We're doing everything except for the asymptote. So we're going to say for domain, we're going to say all real numbers. And then we're going to say except x cannot equal 0. And then for the range, we're going to say all real numbers except y cannot equal 0. And for this, we're only going to worry about that one notation. You can learn the other notation next year, or not next year, but next semester or next year in Math 3, because you'll study these again. And then for type of graph, we'll just say rational. All right. Any questions so far? How do your brains feel? Pretty good? All right, so just like we talked about with quadratics, just like we talked about with square root and cube root, we're going to do the transformations. So I know this has like all the blanks. You guys can fill this in on your graph paper however you want. So we're going to write kind of like where the A value and the H value and the K value, how they look in this specific type of function. So we're going to say f of x equals the A value replaces the 1 on the top. The A value replaces the 1 on the top. So 1 is normal. Anything other than 1 tells you that there's going to be a stretch or a compression, okay? And then on the bottom of the fraction, we have x minus h plus k. So the bottom of the fraction is kind of like, we would think of that as like the inside of the function, but you're not going to necessarily see parentheses. So you're not going to see it as an inside, but it is. It's like the inside of the fraction. And then the plus k is going to be outside of the fraction. So the denominator is going to be the inside of the fraction. And then the plus k on the end of the fraction, that's going to be considered the outside of the fraction. Okay? And the letters, they all still mean the same thing that they used to mean. All right. So H is what type of shift? Yeah, it's horizontal. So it's right or left. And then what is special about the horizontal shift? Yeah, positive is left and negative is right. So it's the opposite of what you would think. What does the K do? The number on the end. K is a vertical shift. Plus shifts up and a minus shifts down. Okay. What does an A do? It does the multiple things, right? Okay, it reflects across the x-axis if it's negative. If it is greater than 1, it's a stretch, vertical stretch. If it's if it's less than 1, squish or compression. Now, just like you guys could get the vertex or the turning point or the end point from the H and the K, you can get the vertical asymptote and the horizontal asymptote from the H and the K. So if we look up here, the vertical asymptote was an X coordinate and the horizontal asymptote was a Y coordinate. So we're going to say the vertical asymptote comes from H. It is X equals H. So it's the opposite sign, just like normal, X equals H. And then the horizontal asymptote is going to be Y equals K. It's the same sign, just like normal. And because they are the equation of a vertical line, the equation of a horizontal line, you can't just write H or just write K. You do have to write it as X equals H, Y equals K. So that's why they say whenever they, whenever I put it on my worksheets, I always say write the equation of the asymptote because it has to be written as X equals H, Y equals K. So don't just say the asymptote is H, the asymptote is K, because that's not complete. You have to say the asymptote is X equals 2 or X equals 5 or X equals whatever, okay? All right. So they say the reciprocal parent function is reflected across the x-axis, translated 4 units to the right and 3 units down. Write an equation to represent the new function and identify the asymptotes. So it's a reciprocal function or a rational function, so it's going to have that fraction in it. They didn't say anything about a stretch or compression, which means the A value, the number on the top, is going to be a 1. But they did say something about it being reflected. So is it a positive 1 or a negative 1? Negative 1. Okay, so we're going to put a negative 1 on the top because it is reflected. It says it was translated 4 units to the right. So how do we make it go to the right? Okay, so do I just put negative 4 or do I put something else with the negative 4? X minus 4. Okay, and then how do I do 3 units down? Minus 3. Okay, so then if I want to do, I'm going to write VA for vertical asymptote, HA for horizontal asymptote. This is going to be X equals, this is going to be Y equals. What is the X going to equal? Four, positive 4. What does the Y equal? Negative 3. Perfect. There we go. So I do the opposite sign of the H for the X. X equals positive 4. The exact same sign for the Y. Y equals negative 3. So we got our HK. Okay. Okay. Do you guys want to do f of x, g of x, y? What do you guys want to do for number 2? Y. Okay. All right, we'll make it a reciprocal function. vertically stretched by a factor of 2, translated 7 units up and 1 unit left. So what should we put on top if it's vertically stretched by a factor of 2? We should put a 2 on the top. So instead of a 1, we're going to put a 2 up there because 1 is normal, and it's not normal, it's vertically stretched by 2. Okay. How do we do translated 7 units up? Plus 7 where? On the outside, plus 7 on the end. Okay. How do we do 1 unit left? X plus 1 on the bottom. Okay. And then we got our vertical asymptote, our horizontal asymptote. So I should be writing x equals -1, y equals 7. Okay? Now, I did not say this before, I should have. For these to be good notes, you need to be writing out these descriptions along with these equations. Oh, I know, it's obnoxious. So let me just pause. I'm just going to sit here and let you guys write those out. This is the most obnoxious part of this note-taking. All right, last one of these. Okay, so we have an f of x, we have a y. What could we do next? G of x. Okay. So it says it has a vertical asymptote, x equals -2, and a horizontal asymptote, y equals 5. So what do you guys think we should do? Wait, do we put the letter A or do we do a number? 1. Okay, 1 over. Plus 2, okay. Is it same sign or opposite? Okay. All right. So we've got some example problems.
I'm not writing BA and HL. No, because they can't see that in the problem. Yeah, but like. Wait a minute. Oh. Yeah.
Okay. So. No, remember, we don't make the graphs this big. They don't need to be this big. We just need to go to like 4. Okay, so let's write the transformations. All you need to do first is write the equation. The graphs do not need to be this big, remember. We're going to draw it, but we're going to draw it really small. Remember, these, you mostly need to go to like 4. But let's find the information first, because then we'll know how big to make the graph. So let's find the information first. So what are the transformations? Just down 2. Okay, so what's the vertical asymptote? 0. Okay, x equals 0. Y equals -2. Okay, so I'm going to draw it on mine, and then once I draw it on mine, you'll know how big to make your graph. Okay, so I'm going to draw x equals 0. and then y equals -2. Don't do it yet. So this is kind of giving us an idea. I should not be doing pink because you probably can't see that. This is kind of giving us an idea of how big our graph is going to need to be. You don't need to go to 10. Does that make sense? Down to, so you probably need to go maybe up to 2 on the y-axis, and then maybe down to -4 on the y-axis, and that's probably enough. Does that make sense? So when you draw your graphs for these, you do not need to make them very big. The 10 to 10 is overkill. You do not need to make them that large. All right? It is way bigger than it needs to be. Because remember, we're going to do like 1 square away from the asymptotes and then like a fraction. So we hardly get any points on these when we draw them. So I'm going to go ahead, once you guys have your asymptotes drawn in, we're going to do the fraction version. So we're going to do alpha y equals 1 over x with a -2 on the end. And then I'm going to hit math and turn it into a decimal so it's easier for me to graph it. Say, hey, take my answers, turn them into decimals for me. And then I'm always going to look for the error because like two numbers up from that and 2 numbers down from that are going to be my easiest points to graph. So -1, -3, -2, -2.5, 1, -1, 2, -1.5. And then you can kind of make your corners. Follow the asymptotes. Okay. So what should I write for domain? Yeah, x cannot equal 0. And then for the range, I'm going to write all real numbers, but y cannot equal -2. So you look at what your asymptote is, and whatever the asymptote is, that's what gets excluded from your domain or what gets excluded from your range. So vertical asymptote, that's the number I got to skip. Horizontal asymptote, that's the number I got to skip.
Just out in the parking lot walking in.
Oh, look, I can use a bar.
Well, it's like you see like the pink ones, the black ones. I've never seen like a vibrant gray. And I really, it matches my pencil actually. I really enjoy that. Oh.
Please don't trade.
Trade masks?
Please don't do that.
I want to play the elementary school. I'll trade you this mask.
All right, how you guys feel about that one? Good? Okay, we're going to try this one.
I love today. Today didn't see something about my mother's popping. You're just jealous you don't have one.
They knocked down having a lane.
I think they did. They just didn't want to. Bro, look at my jeans. They really black me on the balls.
Oh,
Yeah, you think your balls are one of 7 now?
You guys. What?
All right, what are the transformations? Transformations, what are they? What are the transformations?
Down 2.
Right 2. Stretch 3.
Down 2.
Right 2. Right 2. Stretch 3.
Oh, I wrote the down. Down 2. Down 2.
Okay. So this is what it looks like when we graph it. You can do more points this time. Okay. Everybody doing all right? All right, I'm going to put the assignment up on the notes and the assignment up on Canvas. There's 4 more problems on the notes that you can finish. And then there is going to be the assignment on Canvas. Huh? Yeah. I think we got plenty of time. So I'm going to go ahead and write the ones down that are on here. Okay, everyone done looking at number 7?
No.
Here are the other 4.